right? Always poke the button. I do see Dominic. I don't care what your neighbor knows. I want to know what you know. Remember, you can look at what your neighbor's doing. You can copy down their stuff. You can ask them what they're doing and thinking. You can end up with 4s and 5s on these, and it'll all look great until you go and take your quiz, and now you got a 50. Okay? That's what matters. The tests are what matters. This is just a gut check. Be honest with yourself. I saw Ava. I saw Killian, Gianna, Aiden, Grace, Keely, Sailor, Joe, Maddie. Maddie was somewhere in the back, but then I moved stuff. Oh, there we go. Preston. Okay. Sophie's here. After, oh, that wrapped the text on it. Peyton. There we go. I need to fix that in here. And Brennan. Am I getting names wrong, or do I not see a Brennan? Okay. All right, cool. Is anyone still going? Okay. You'll pick up what we did real fast. Just the first 2 quizzes won't matter. Okay. Known? We're all good? We're there? You have the graph and the table and the equation? The confused look on your face says no. Okay. Would it help if I said the word perimeter? Like yesterday? Number of squares to perimeter of figure? If I say those words, does anyone need more time? Do thing now. It was close. Thank you. You know, you're the last group to come up to the high school that had access to Makerspace. Any of you ever go to that? Middle school? Makerspace with Mrs. Bowerly? Okay. Yeah. All right. I was just curious. That's all these bulk donated cards. We used to go down to the middle school. We'd teach middle school kids how to play different games every now and then. And we'd give them a bunch of crap load of free stuff. So now that Makerspace isn't a thing anymore, We've just got this pile of cards that we need to get rid of. Okay. Starting with define your variables, describe the relationship shown as a table, graph, and equation. I'm going to say x is number of squares. So I will also label my graph x-axis as number of squares. I will label y as my perimeter. I will label my y-axis as perimeter. And I will make table. I will fill in table so I can make the graph, so I can make the equation. Just like we did yesterday, or 2 days ago. We did it 2 or 3 times. Said I wasn't really a fan that they used the geometric example, but then we figured let's just do table, then graph, then go backwards for the equation. And it seemed to work a lot better. So, if I got uno square, what's my perimeter? 4. If I have dos square, 6, right? If I got 3 squares. So what's going to happen when I go to 4, 5, and 6? Add 2 every time. So, it kind of depends on what you did for your graph as to how much space you used. For me, I've got about 10 boxes, right? 10 boxes. If you didn't do these parts, that would still make a decent graph. I'd be okay with it. I'd say like 4 points at a minimum so we can start to see the pattern. So if that's the case, then I can just go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I tried to pick something that was going to go by ones. And then plot your points. 1, 4. 2, 6. 3, 8. 4, 10. Connect the dots. There's your trend. Again, it depends on the space that you used. If you had a bigger graph, if you use more space, completely dependent. Your graph might look a little bit different. Now that I've got that, we said, and this is the big kicker, this is the thing that's going to keep coming back to us over and over and over and over. Y equals rate. How much is it changing for every x? And where do I start? Now the start is always when x is 0. And I can figure that out either by the graph or the table, working my way backwards. And that was the thing that kind of threw me for a loop, is them using the geometric examples. We would think I have 0 squares. The perimeter is 0. There's nothing there. But if we were to take these dots and work them backwards the other way, if I were to add 2, add 2, add 2, go the other way, that means I'm starting at 2. And you said my rate was, one of you said my rate was also 2. There you go. That's it. No words, just math. Do you have the table? Okay, did you say x and y, squares and perimeter? Did you label? Do you have a table out through, well, we already have 3 of them. I would hope that we took it at least one more so we can confirm our pattern. Do you have the equation? Do you have the graph? Do you have the labels? 5 things asked of you and 5 points. Now, if for some reason we went all the way back to table zone, what happens if you flop those? What if you said, if the perimeter is this, that's the number of squares? Your entire, everything up here would just be flippity flopped. Your table would be upside down. Your graph would, instead of going up sharply like that, it would be slowly ascended instead. It would have a 1/2 slope. X, y thing, -2, 5, that would be y equals 1/2 x minus 1. If you did that. I don't know if did anyone swap their x's and y's. Okay. Make sure you say what it is. You got your work, you got your graph, and next to it, what'd you do out of 5? Okay. Said the easiest ways to do this, to be organized, we had some issues with organization last semester. Nice and simple. Homework on one side, daily quiz on the other. Put it in a little box at the bottom of the page on your homework. Or, say it's 1, 2, 3, 4, 5 pages of assignments. Here's a page with all my daily quizzes. Whether it's a notebook, a binder, wherever, just try to keep it organized. Okay? If you want to see organization and how it should look, okay, Grace's was pretty good. Keely's was great. Sophie's was pretty good. Okay. Check their stuff. It's pretty simple. Just that's part of being in high school is the unwritten curriculum of how do I even organize my life. So, you. We only had, what, 4? 4 problems? There wasn't much. I don't want to give you a crap ton of homework. Go live your life. Great. Now talk to me. Do you have any questions? Today is what, Wednesday? Yeah. In the last 46.5 hours, I don't think anyone's asked a question other than what the crap is going on. We'll get to that in a minute. Yes, ma'am. Well, oh, yeah, if you got a question about your daily quiz itself.
I know I did some stuff wrong, but
okay.
I didn't label these, but I did have them correct. X and Y's. Oh, no.
Oh, well, that's 4 out of 5.
Okay, and then I just didn't add my...
Oh, you missed your start. You know what? Since it was a little thing here and a little thing there, I'll combine them and say a thing. Because you put it in words.
Yeah.
You put it in words, so I'll take that. Go 4 out of 5. Yep. Nothing? Okay. Now, freshmen might be used to being in trouble, getting grumbled at after this. Real talk. Who actually did the assignment? Like, you actually did it. You opened a book, you clicked a thing, you put stuff in your notebook. Okay. Come grab a book for me.
I have a book. I just didn't remember what question it was.
Oh. Wouldn't let you use the computer either?
I tried, but it wouldn't let me log in. I don't remember the password or something. So it wouldn't let me until...
All right. Y'all are... Okay. Y'all look around at each other's faces. I guarantee you got each other somewhere on social media. Blast it out to the group. Hey, who's in Sullivan's Algebra? What was the homework? Right? Like, get her done. All else fails, wander by here. I mean, I'll be in the middle of a lesson right now, and I'll have one of my pre-cal kids wander in and say, "Hey, is plan book right?" "Yeah, no problem." And then they move on with their life. Come in and double check. "Hey, what's the homework?" "Okay." "Yes."
Will you post the solution?
"Yes, I know I need to." I was buried under that, all of those binders. So eventually they will get there. Yeah.
So you post the solutions.
Yes, the solutions should be all online. Not just the answers, the solutions, how to get to them. It's just I have to go through and individually download from every lesson and then throw them in the folder. And I just honestly haven't had time to do that. See, funny thing about a worldwide pandemic is we're having a lot of kids absent, which means I had a lot of kids who missed their last few quizzes, missed finals week, and I've been scrambling trying to get them caught up. I've been spending my time after school, my prep, Spartan time, making sure that those kids get caught up. So sometimes stuff like having the solutions on kind of falls by the wayside. Okay, so as soon as they are in, though, I'll just send a reminder out. I'll send it out on Remind and say, hey, all the solutions are in there. Here's a direct link if you want. Okay. All right. Before we go into this, I got to ask the question now because yesterday I had a bit of a freak out, and then I went and talked to Mr. Skoglin, and he had already freaked out. How many of you did the pilot program with Skoglin last semester? You were in a different book. You were in the thinner Envisions book. Okay, 3 of you. Maybe 4, 5. Okay. So here's the deal. Every so many years, we get new books. These books, they're old, they're trash. Some of the examples in them are even like sketchy to say out loud. Yeah, it happens. We're in the process of a buy year. That means all the math teachers picked a book from different publishers and we're giving it a trial run. We're seeing how we like it. We're comparing notes. What about the scope and sequence? What about the pacing? How about the difficulty? What does the online stuff look like? Mr. Skoglin had one of his 5 algebra half sections that was using a different book, a different curriculum, a different everything. And from the beginning of the year, he said, wow, this is head and shoulders. It starts 2.5 months past where we start. And had to do a lot of supplementing. Do you remember at the beginning of the year, it was rough. Like, people got wrecked. He was under the assumption that everyone who was in that class, in that pilot group, stayed in that pilot group with him for the year. And what happened was anyone who was in that class was scattered to the 9 winds because we have 6 or 7 different sections of algebra half. So that meant some of the kids who were in the pilot group who have done stuff that we're going to be doing for the next 2 months in all of the other classes. You already went through it, just at Mach 2. You went through it way faster than you should have. Probably didn't go so well. And then you had the other kids who were in algebra half, this book, the other 90% of students, what happened to those kids who now went into the pilot class? They are jumping from, we are just talking about linear relationships and what a graph is and how to label your axes correctly, the foundations of it. They're supposed to jump all the way past how do I make slope-intercept form? How do I do standard y-intercept form? How do I do point slope form? How do I do word problems? How do I do function notation? all the way to systems. They're supposed to jump across 2.5 months of content without ever having seen it. So there's a huge disconnect between the pilot group, the pilot book, and all of the other classes. So if you were in that pilot group, you are starting back, you're going to do a rewind. You're going to go through stuff again. We are just now starting linear relationships, nonlinear relationships, graphing by table. We are going to start into slope and slope-intercept form because that's what the other 90% of students did. Okay? That's what everyone else did. That's what Algebra Half has been for the last 20 years. That book assumes that everyone knew all of that coming into the class, because you should have learned that in 8th grade math. Should have. So, it's hard to describe the whole situation without the word cluster. And the kids are the ones who get caught in the middle.
Oh, can I have the office?
Oh, yeah. So, we are going to rip through 4 pretty fast. We'll probably bog down in 5 and 6. Okay? We're halfway through 4. I expect we're going to be done with chapter 4 fairly quickly. 2 weeks, tops, and that's every other day. Then we'll move into 5. That's all the linear equation stuff. 6 is our systems. 6 is where our chapter 6 is that book's chapter 4. So, Mr. Skoglin had an emergency meeting with our curriculum director and our administrators, and they are tossing that book for all students for the remainder of the year. So if you were in the pilot group, no one's using that book this semester because it went too fast for 90% of kids. Okay? Now, you look like you have an opinion. State it.
I thought it was fine.
Yeah. See, that's what happens with Algebra Half. There's a lot of kids who will come into Algebra Half having never done a single shred of math in middle school. You just keep getting passed up the grades. So we have kids coming into Algebra Half who don't know how to add a positive and negative number because they never did it in middle school and they never had a consequence for it. You also have kids who probably could have gone into Algebra 1 but chose to do Algebra Half to bone up on the foundational skills. Okay? Algebra Half is the lowest our math goes. This is the bottom floor. This is the foundation for everything else you'll do for the next 4 years. We can't change it. But we did collectively as a group decide Algebra Half will stick with these books in the future. We're just going to keep Algebra Half this. Algebra 1 will probably switch to the Invisions book. So, just I believe in everyone knowing what's going on, getting you the information so there's no rumors, there's no crosstalk, there's no, well, this class was harder, that class was easier. It was literally a giant cluster. If you were in the pilot group, you were supposed to stay in that class year long. And that was a miscommunication with our guidance office. Okay? But that entire class has been split up among the 200 some sections we got. So it sucks. So everyone in any class is now in this Pearson book. Okay, all sections will be in this, mine and his. If you were in my room last semester, we'll just keep doing what we're doing. We're still going to get past 6, probably 7 by the end of this semester. If you were in the pilot group, you're going to have some review. Take it as an easy A, chill out. Okay? So, fill in the table. Argue with your neighbors. What goes where? Can you determine a relationship from a word problem, from a picture? Can you fill in a table? You don't have to whisper. Talk. Like, have a discussion. Yeah, we should probably have those. Okay, can you just figure out a relationship between I want to have this many steps, so I have to have this many blocks? Can you write those as coordinate pairs? Remember, it's x, y, input, output. Okay. I should see, does green show up down here? Oh yeah, green shows up good. Okay, from here, to add another step, it was the same number of blocks plus another one. So if I want another step, it's the same number of blocks plus another one. So 4 more onto this, 10. 4, 10. You start to see the pattern. The number of blocks goes up by 3, or sorry, up by 2, up by 3, up by 4. Next time, up by 5, getting 5, 15. All right. Copy complete table, did the thing, is a relationship of function. Remember our function talk yesterday, 2 days ago, was to be functional. Think of a functional machine. I press the button, my volume goes up. I press the exact same button again, it switches over to Netflix. That is not a functional machine, right? I lay on the horn, it lets the guy know he's a jerk. I lay on the horn again, and my trunk pops open. Not a functional machine. Every button should have one purpose. Every input should have one output. So look at all of your inputs and say, did the 1 do a thing? Did the 2 do a thing? Did the 3 do a thing? Or did any of them ever repeat? Did I get a 3 and then a 3 again, but it did something different? No. I only used all of them once. So yes, is it a function? I would say yes, because every x goes to 1 y. That is the literal definition of a function. Or if you want to get a little more technical, every element of the domain maps to exactly one element of the range. But then it sounds like you're just being a pedantic jerk by trying to use big number or big words. Okay. So a function is anything that has input, output, maps one, done. check out the name of the lesson. It is patterns and nonlinear functions. This was not a line, right? If I were to plug this into a graph, see how it kept going up faster and faster and faster? We had a couple like that in 4.2, where it tripled its distance every time. And those were exponential functions. They kept getting larger at a much faster rate than just a line. Those are the difference between linear and nonlinear. Pretty simple. Linear makes a line, nonlinear doesn't. Okay? Nonlinear functions. These, you'll see, we might do these by table. Graph by table is the fallback option of all math. But you'll see this in Algebra 1. You'll see this in Algebra 2. You might do it by table in here, but actually what they are and how to make them and all their properties. This, I don't know what your middle school experience was. You ever see that symbol before? What is it? Oh yeah, we did that last semester, right? Absolute value equations. Okay. Absolute value means that if 3 is 3 units away from 0, then negative 3 is also 3 units away from 0. That's why it has that symmetry to it. Okay, so there you go. Just examples of them. Linear or nonlinear, pretty simple. Can you make the graph? And then just tell me if it's a line or not. But I put this in here because we need to practice making the graphs in the appropriate scale. Having an appropriate scale is something that kids tend to struggle with. So, area in square inches of a pizza is a function of its radius in inches. The cost in dollars, the sauce of the pizza, weight ounces, blah, 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 blah. They have a comparison. Radius to inches, weight to cost. Graph both. It doesn't even matter what we're talking about. They want you to graph two tables. So you have to pick a scale that's going to fit all of this data. Label your X. There you go. Your X and your Y. Label, this is radius in inches. Label, this is area in inches squared. Put a big honkin' highlighted capital letters note to yourself. Y'all, you don't have a graph until you label it. I don't care if you got numbers on the side. You need to label what does it even mean. If I say I'm about to give you, okay, I'm going to give Dominic 3. Because Dominic just walked in the room and has no idea what I'm talking about. I'm going to give him 3 of them. Is this good or bad? Right? Am I going to give you 3 packs of magic cards because you're a crack addict now? Am I going to give you 3 smucks upside the head? Am I going to give you 3 alien monkeys that are trying to eat your intestines? Like, the label matters. So please put the labels on there before anything else. Next up, check your X's and make sure what size of scale do I have? How much space do I have? How many boxes do I have? What is a reasonable scale? My numbers go from 2 to 10. How many boxes do I got? 12? Do I got enough room to fit them all if I go by ones? All right, go by ones. The radius in inches is starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But my area, I can't do that. The lowest that ever went was 12-ish. Imagine that, a pizza with a radius of 2 inches. That's like the personal pan ones. little bitty ones, or the Red Baron 2-pack that you get, the microwave ones. Okay, all the way up to 314 and change. I have, is it 12 again? So what scale could I reasonably go by that I can go from nearly 0 up to at least 314? Okay, well, check. Do 314 divided by 12 boxes and say this is the minimum. I have to go by at least this or bigger. Take the space you have, divide your data by that. What does it say? 26 and blah, 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 right? So 25 would be close. Do you want to go 25 and just go a little bit off-road? Or do you want to bump it up and maybe go by 30? 50s. Have an opinion. This is the part where you talk. Wow. What about Tom? What does Tom think? Yeah. Do you want to go by 25s and just end up a little off-road? Do you want to go by 30s so it fits? Do you want to go 50s and make sure it fits? What do you want to do? I don't either. That's why I'm asking. Sailor. Okay. Hey, look at that. Someone had an opinion. Welcome to democracy. If not enough people are voting, the loudest voice is going to win. I'm going to go by 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600. Okay. Sailor has spoken. Need to get you the little staff like the Ugnaught from Mandalorian. I have spoken. Peace out. Right. Okay, plot your points. At 2, 12.57. That's like barely off the line. Because remember, that first box is 50. At 4, 50.27. So pretty much right on that intersection. Get the rest of them. You're going to have to guesstimate them a little bit. Plot the rest of them. Remember, each box is 50. You're going to have to ballpark it somewhere in there. We got 6, 113, 8, 201, 10, 314. Okay. Y'all, as we move into this semester, we're going to do a lot of stuff with lines, linear equations, systems of linear equations. You better have a straight edge with you. At the bare minimum, every one of you should have an ID. You need it to get in the building. An ID, a debit card, a driver's license, a Qdoba gift card, I don't care. You should have some piece of straight plastic on you. If you don't, the edge of your notebook, edge of your binder, edge of the textbook. If you don't got enough buttons or a really weird case, maybe just the side of your phone case. Can you line this up with a straight edge?
No.
Okay, and you see it curves. It has a curve. It's not a line. In fact, this is a really, really stretched out quadratic. So I would say nonlinear. I know that you can plot points. The reason that I'm taking the time to go through this instead of just blasting past it, y'all, I teach everything from pre-algebra up through pre-calculus. The entirety of the high school curriculum. And I can tell you over and over and over, from basic draw a line up through partial fraction decomposition of rationals. Kids cannot make a graph to save their life. They can't put a scale on it without explicitly going through it. So we're going to take our time to make sure, can you make an appropriate scale? Can you make a scale that fits your data? Y'all remember the, do you still do D-step tests? The standardized tests? You have the math portion, the English portion, and then the history portion, and then the science portion. You do them all throughout middle school. You're not going to do another one until next year as sophomores, pre-ACT. The science sections are almost always, can you read a graph? Basic science knowledge, like, what happens if I take a big honking basketball-sized chunk of potassium and throw it in a swimming pool?
That sounds fun.
It explodes.
Yeah, I know. That's why it sounds fun.
Yeah. It actually explodes. There was a teacher about 15, 20 years ago who made national headlines for doing that with his science class. He was kind of stupid. He took a chunk of potassium like this and just threw it into their school swimming pool. You ever seen an actual cannonball explosion? Like that, except it burned the skin that it touched. Like a bunch of kids walked away with third-degree chemical burns. Yeah, it was pretty wild. So, please tell me, where's the thing? Yeah, there's the thing. The second one, I want you to try to make a scale. Argue with your neighbors. I'll tell you right now, 2 through 10. The x-axis, you can go by ones. Can you think of an appropriate scale to fit that data onto the y-axis? Plot your points, label everything. Okay? Being able to read and create a graph is paramount to the next 3.5 years of your academics. Okay, less explosions, more math. I know explosions are fun.
You don't even need that much because any size.
Yeah, potassium is extremely reactive. Any of the alkali metals like that, like pure salt, if you actually have pure sodium, not sodium chloride, pure sodium, it'll do the same thing, just at a slightly slower speed.
But it has to be stored. Mineral oil or any kind of oil.
Anything that will absorb the moisture and keep it away from the element itself, yes. Please do the math. Let's not talk about explosions until after class, because I actually like explosions and that'd be fun. I grew up an only child on a North Dakota farm. I learned how to make thermite just by experimenting. So, you're talking to the right guy. There's a lot of my shirts that I can't wear to school anymore because they have holes burned in them. Okay, looks like most of us got it fairly quick. I'm going to say, here's my weight in ounces. I'm going to label this as my cost in rubles. Dollars. I just wrote it sideways, so it sucks. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yay. Who went by ones? Will I fit all my data? It. Oh, on the y-axis. Who went by ones on the y-axis? Okay. You can, right? Like from 0 to 4. Now your line, if you go 0 to 4, is going to be very shallow, right? Who chose something different?
I went by 80.
By 80 cents a piece? Okay.
Went by 0.5.
50 cents a piece?
I went by 20 cents a piece.
Does it fit? 20 cents a piece, 12. That only gets us to 240. You'll fit 3 of your points. You will be able to see the relationship between them. But it's not enough to fit everything. So we want to go a little bit bigger than that. So could I go by 40 cents?
Yes.
Yes, I could. So 40 cents, 50 cents, $1, any of them. 40, 40, 50, $80. Yeah, 40, 50, $80. 40, 50, $80. Let the dice gods decide. 40s. So I got 40 cents, 80 cents, $1.20, $1.60, $2, 240, 280, 320. There's things that I don't want to know about my students, and whether they have crabs on their underwear is not one of them.
Let me rephrase it. I got crabs on everywhere.
There are things about my students that I don't want to know, and whether they have crabs on their underwear is one of them. So, plot your points. 284, 160, 6, 240. You laugh, but that kind of actually fits the MO in here. I had a kid end up in my quote book last semester, or I got put in my own quote book for, why are your pants on your ankles? I kid you not. I looked over and I saw a kid in the first row, and all I see is legs and his pants around his ankles. He was wearing shorty shorts and just decided he was hot, so he was going to take his sweatpants down. But boy, is that an image. Mr. Dawson Wood, if you know him. Fun guy. All right. So, sounds like we did okay, depending on what our scale was. I know. Oh, back to this. Was that linear or nonlinear? Okay. I want to see you do this one because I know we are terrified of the fraction. I want to see how you come up with the scale now that there's fractions involved.
I was your 100th subscriber, by the way.
Oh, sweet. All right, fam, we're going to do a giveaway. We don't do that here.
Wouldn't it be easier if you would grab
Wait, can we have more time? We're doing really good.
If we got enough time to argue about who's better at math, I bet we got time to do the graph. Now we're going to be doing a bunch of stuff with graphs. I told you before, make sure you have graph paper. Okay, I'll always have some spare up here. But getting yourself a graph paper notebook and just doing your assignments in there for the rest of the semester would be a good idea. The notes are pre-printed like this for you so that you don't have to wing it on a graph in a notebook. So you should have everything in one spot, all nice and neat and organized. Okay, I'm just trying to reduce the stress, reduce the amount of stuff that you have to come up with on your own. Now, I didn't use I could go by ones for my x-axis, right? No biggie. Could I just say 0 through 6 and just skip a line every time? Now, I can't actually do half a cut. Like, it's either you cut it or you didn't. But I can do this. Just showing you. Now, I'm going to go all the way out to the full 12 just so you can kind of see what's going on later. Okay. Where are my woodshop kids? Who lives with that tape measure clipped to your belt? Okay. You always got those kids. These numbers look familiar?
Yes.
They're just from a tape measure. It's half each time. Half of that, half of that, half of that. If I go from a half to a quarter to an eighth to a 16th, what's the next one? 32nd, close. And then a 64th, and then a 128th. And at that point, you're just like using a Garrett wire to go through it like a block of cheese. I need to go from 1/16 at least, so probably 0, up through a half. And I've got 12 boxes. Y'all, I can just go by 1/16, 2/16, which is 1/8, 3/16, 4/16, which is 1/4 when I reduce it, 5/16, 6/16, which is 3/8, 7/16, 8/16, which is 1/2, 9/16, 10/16, which is 5/8, 11/16, 12/16. Okay? That'll fit everything. I went by 16ths, and then I just reduced my fractions along the way. Okay? So instead of calling this 8/16, I called it 1/2. Okay? So if I just count by 16ths and say this is the number of cuts and this is the fraction of area, now start plotting points. 1, 1/2. 2 cuts, 1/4. 3 cuts, 1/8. 4 cuts, 1/16. We just said it. What's going to happen at 5 cuts? 1/32. Isn't it always half each time? So I went half as far. I went half as far. I went half as far. Go half as far. Go half as far. Go half as far. Go half as far. If I keep cutting something in half, will it ever be, and that is one of my questions, will it ever be 0? Okay? So if I take Peyton, I'll launch him up in the air, and I fruit ninja him on the way down. And I keep cutting him in half. In half, in half, in half, in half, in half. I'm able to freeze time and just keep slashing him in half. Is there ever 0 Peyton?
No.
There's Peyton soup, but there's no 0 Peyton. This will eventually just kind of come down here and curl along the axis here. This is an exponential, maybe you've seen this in physical science, decay model. Exponential decay. See, it's going to creep along 0. The classic example is, what if you want to go buy a new laptop and it costs $2,000? And they printed a coupon in some magazine and they didn't edit it well because no one actually looks at magazines anymore. And they didn't put in the fine print, limit 1 per customer. You're like, all right, here we go. Boop. $2,000. Coupon. $1,000. Coupon. $500. Coupon. $250. Coupon. $125. You just keep putting those coupons down. Is it ever actually free?
Yes.
Eventually, it's worth like belly lint, and they're just going to give it to you and say, "Stop putting coupons on my desk." But it's never actually technically free. It might be a fraction of a penny, but it'll never actually hit zero. In Algebra 2 and beyond, well, we'll call these like creeper functions. See, it's kind of like a creeper, right? He's hanging out in the bushes right next to your living room window, and then someone spots him and he takes off. Okay? So, no, that is nonlinear, and it will never hit zero. Okay. So representing the patterns in nonlinear functions, isn't this what we just did? Fill in the table, make words, equation, graph. Fill in the table, words, equation, graph. That's what we were doing last time. Now it's just the equations are getting uglier. Can we make the equation from something that's not a line anymore? Let me double check what we got here. Problem 3, right? Oh yeah, we got this. 1, 3. Has roll 5 to rolls. Okay. Okay. So, do I got any Rubik's Cube kids in here? You'll always get that kid who like wants to speed run them. Anyone? No? Okay. So a 3x3 Rubik's Cube, if it's 3 wide, 3 deep, 3 tall, you take 3 times 3 times 3, there's 9 total blocks, or 9 on the base by 3 layers, 27 total blocks there. What would happen if you had a 4x4? So it's 4 wide, 4 deep, 4 tall. Well, what's 4 times 4 times 4? Use your resources. Calculator. Press buttons if you don't know. It is 64. Best game system ever made. Okay. What about 5? It is 125. Okay. Okay. What pattern can you use to complete the table? What are we doing every time? What am I doing to these numbers to get to these numbers? No. Cubing. Right? Squaring is when it's times itself. Cubed is when it's times itself and times itself again. 3 of them. So what pattern can you use? I can use y equals x cubed. In fact, not only is that my pattern, but that's my equation. Y equals x cubed. Whatever x is, cube it, that's y. Okay? And then, with words, I would say the number of blocks or cubes is side length cubed. Graph. What's a reasonable scale here if I need to go to, in my table, at least 125, and I have, looks like, 12 boxes again?
9.
9 by 12 is not 125 or more. Okay. Now, if I did 10, I'd be close, right? I could go by 20s, I could go by 25s, I could go by 50s. Well, 50 might be overkill. 25s, 25s would fit it, yeah. Here's what I'm going to do. If I take 12 boxes times 10, that's 120, and our last data point is 125. Are you willing to go just a half a box off-road? Okay. So you can do what you want. You know what? Do what you want. You can go by 10s. You can go by 20s, 25s, 50s. I don't care. I'm going to put on here 0, 2, 4. Back that math up. There we go. 6, 8, 10, 12. This is side length. This is number of cubes. Okay. You do you. Are you going to go by 10s and then just a little bit off-road? 20s? 25s? 30s? Hundreds? $14, $40,
I have a question.
$288. Hi.
For the labeling on the graph,
Mm-hmm.
cubes be on the bottom.
Number of cubes. Okay, this is technically what I'm supposed to write. I just got lazy. Number of blocks on an edge is my side length. Total number of blocks is the number of cubes in the whole thing. I just got lazy. Okay. Call me out. Okay. They literally tell me what X and Y are right there in the table. It was less of a correction, more of a it was on the border. I'll call it a bullet graze. You get close again, we'll combine them and call it one. Here's what I'm gonna do. I went big. Because look at what's going to happen. The further I go, do you know your cubes? Do you know your cube numbers? What is 1 cubed? 1 by 1 by 1. So 1 cubed is 1. What is 2 cubed? 2 by 2 by 2. 8. What's 3 cubed?
27.
It's right there. 27. Okay. 4 cubed, 64. 5 cubed, 125. 6 cubed, 216. 7 cubed, 343. 8 cubed, 512. 9 cubed, 729. 10 cubed is 1,000. 11 cubed, 1331 is off-road. Okay. So that's why I went big. You don't have to go big. We only had 5 things in our table. You could have gone by 10s and then just gone a hair off-road and you'd be fine. Okay. So what is a pattern you can use to complete the table? Cubes. Cubes. Represent the relationship using words, check. Equation, check. Graph, check. We're good. Okay. I'm going to assume you can do that again because this is literally just cubes again. The practice example is just do the cubes again. Okay? So on this, you're just going to put a big old, yep, because we just did it. But what happens when I take away all the stuff? This is more common, this is more emblematic of a homework assignment, of a daily quiz, of a test problem. There are your ordered pairs. 1, 2, 2, 4, 3, 8, 4, 16, 5, 32 represent a function. What rule represents the function? If they ever ask you just, here's coordinates, what's the rule? I want you to write on there, step 1 is to make a table. X, Y, fill in the table with your coordinate pairs, X, Y, 1, 2, 2, 4, 3, 8, 4, 16, 5, 32. Can you tell me what's going to happen on the next 2 blocks? 64 and 128. What are we doing every time? Multiply by 2. So what is a rule that represents the function? Step 2 is, how is y changing? So you said that they're multiplying by 2. Do you know what it's called when you repeatedly multiply by the same number? 2 by 2 by 2 by 2 by 2 by 2 by 2. I don't call this, where was it? Exponents. The thing that I'm repeatedly multiplying is 2. I'm taking 2 to some power. Now ask yourself, is it going to be 2 to the x? Is it going to be 2 to the x minus 1? 2 to the x plus 2? What happens if my table started at 1, 8, 2, 16, 3, 32? Then I would have to monkey with my exponential value here. In this case, is 2 to the first 2? Is 2 squared 4? Is 2 cubed 8? Okay, then that's just my pattern. Y equals 2 to the x. That's it. That's how you do these. Make a table. Look for the pattern in the table. Maybe we should write next to the side of this, if I ever have repeated, that's an E, I swear, addition or subtraction, then it's going to be multiply or divide. If I ever have repeated multiplication, then it's going to be an exponent with a base to an exponent. Okay. Poke. Okay. If I have repeated addition 2 plus 2 plus 2 plus 2 plus 2. Couldn't I have just said 2 times 5? Because there were 5 of the 2's. Versus 2 times 2 times 2 times 2. Now that is an exponent. Okay? So you're looking for which pattern. I don't think we're going to have patterns any different than that in our assignments. If we do, reason it out. What are they doing every time? How does it change every time? And that's how you make your equation. Number 3, get it. Start with the table. List it out as a table so it's easier to see the pattern. Like, what are they doing every time? Are these special numbers that I should know? Like, if you just happen to know your cubes, well, that previous problem would have been fine. Yes, ma'am?
Would that be right? Could you do
Yes,
that?
it is. That's exactly correct. Okay, I'm hearing a good number of you say the magic words. Yes, those are all squares. Okay? 1 squared is 1, 2 squared is 4, 3 squared is 9. Those are my squares. Now, if you just recognize that from the coordinates, you don't have to make the table. You just... The table is what helps us to see the pattern sometimes, because I don't know about you, but doing XY, 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 instead of all the X's, all the Y's, it's like when you make a Lego set, please tell me everyone in here plays with Legos. Please. Don't let your childhood die. Legos are amazing. Okay? Or if you did in the past, are you the chaos kid that just opens all the packs, dumps them on the table, and just hunts? The look of terror on Keely's face right now, like, why? Or do you keep this pack stuff together and that pack stuff together and that pack stuff together? Or do you organize all the black ones over here, the gray ones over here, the green ones over there?
They kind of just end up in the pile by the end of it.
Chaos. Or do you or don't follow the directions, just get the pieces and make my own? Or do you organize it in some way? Do you put all of the flat plates over here? The round cylinders over here? The bricks over there?
That's an OCD.
No. There's people overuse the words OCD. They really do. That is not OCD. OCD, if you know someone who actually lives with it, it controls your life. But the table is just a way to organize it. If you want the table, do the table. If you don't do the table, I don't care. That's it. Right? Yeah, that's it. Oh, whatever that page is in the book. I got to make the assignment. I didn't know how far we were going to get.